All right, we're recording. So, officially, welcome to the first day of Cult of Rig. Now, where to start? So, I guess I'm gonna ramble on for like maybe a couple minutes about what this is actually gonna be about and all of that. So, I've wanted to do something like this for quite a long time. I've done workshops and lectures and things like that, and the workshops were actually like 8 or 9 years ago, repeated a couple times. But I never quite found the right format. And then to give credit where it's due, about 3 or 4 years ago, programming live on Twitch and some events coming from hackathons and stuff like that started becoming prominent, and that was pretty interesting. Then, probably a couple years ago now, Handmade Hero, which if you don't know, you should actually check out, established the format of, in his case, streaming every day, case Moratori. And that is strictly game development, and it's a dive right in the very, very technical deep end of the pool. And anyway, like that suggested what the format could have been, and I actually quite like it. And I decided I want to do something like that. There's a few people that are in chat, probably have heard about this for me talking about doing it for quite a while now. So now I'm doing it. And as for what the format itself is going to be about now, I think I said it in the announcement video. It's here and there in a couple pages. I'm gonna run it in seasons. Thought about it for a while. We'll see how this pilot season actually turns out, and might tweak the format a little bit. But I'm pretty convinced that this is what I want to do. So there's no real duration or number of episodes to the season. But from here to Seagraph, which is end of July, I'm gonna do some limited streaming. Maybe a couple times a week for an hour and 15, an hour and a half, whatever works. And if this goes well and the format doesn't need major tweaking, then I'm gonna take a break for Seagraph because I'm gonna be abroad, obviously, and then we're gonna start in earnest after Seagraph with the first season. Now the idea is, for every season there's gonna be a new rig, and this is gonna escalate in complexity. So actually, I was messing around with some models. So we're gonna start from the dumbest, easiest possible thing that you can think, which is going to be a unicycle. And I know some people just beat themselves with excitement at the sight of these. Probably not going to do a lot of rigging itself today, but the idea is we start with vanilla Maya, or whatever application you're using. I'll provide the geometry. I'm not going to do modeling work on stream. That's a waste of time. So I'll give out the G on Creative Commons, or if you can model yourself a couple primitives, you're good on your own. So this is the simplest possible thing. Gonna start vanilla Maya, discuss several things that go into deciding how you organize a rig and what you make of it and how you deliver it and things like that, from absolute nothing. Then performance is gonna be a big part of this. I pretty much believe that performance is the absolute number one priority in a rig. You could argue stability of transforms, but let's say that's axiomatic. So if your transforms or your application are unstable, you shouldn't even start. Fix that first. Then what is going to happen? We're going to escalate that technically through several stages. So it might start with just vanilla Maya. Then we're going to look at what's killing performance, which might be mail expressions. It might be a number of other things. We're going to escalate those to better nodes. If we're missing a node that we need, we're going to write the node. So that's the escalation on the technical development end, which I'm very much interested in showing. The other escalation of concepts is, and this is probably one of the things dearest to me, is very often I've seen rigging in education at least presented as a bunch of techniques of sequences of things that you click about. So for years I've seen the most mundane things named and treated like if there's something special. I've heard things, and this one is the one that baffled me the absolute most. Somebody was looking at a rig that I was putting together, and they were like, "Oh, you're doing the broken hierarchy thing," and I was like, "I have no idea what you're talking about." But apparently there is there's a name for, you know, not having everything in one single hierarchy. Um, so, and something that's going on in chat, by the way, if you're not seeing the video itself, refresh the page. Apparently, if you join the chat before the stream starts, you will not see the video. If somebody that has the video can type it in chat, please do. Anyway, so that's the other part of the escalation, which is there's a bunch of notions. Some of them are mathematical. Some of them might come from other disciplines, you know, development, engineering, several branches of design and stuff like that. And again, I'm always mystified when I see these things presented as techniques. Spines is another big one where, you know, I constantly hear people, well, not constantly, but frequently hear people saying, oh, you know, you're doing an Eisner spine or you're doing a ribbon spine. And say, there are pretty sound, very approachable mathematical concepts behind all of those things that do not require that you learn, you know, you need these 500 clicks. You do not, you know, you do not need to learn the Street Fighter combo of how to rig a spine. Now, so that's how I'm gonna go about it. Start with the simplest, dumbest thing. Do it in a vanilla application. Go over what changes and what the principles governing those changes are. Whenever we encounter something new, which, you know, in the beginning might be the simplest things like algebra and then trigonometry and linear algebra and so on, go into those subjects piecemeal. And that's the other big part of this for me, which is maths and development very often are introduced what you can think of vertically, I guess. So, you know, you discover that you need vectors and you look at vectors and you find that, you know, they're linear algebra. So you go, okay, you go on Wikipedia maybe and you start looking it up. And instantly you're vertically introduced to everything that pertains to linear algebra and vectors. So within 2 paragraphs, you encounter eigenvectors and you go, okay, what's an eigenvector? You probably wouldn't have an application for an eigenvector for like months to years, even if you proceed at a pretty brisk pace. And the same is true for a number of other things, like calculus scares a lot of people off, apparently, because when you encounter it, it's presented like vertically and harshly, and with, you know, everything in the kitchen sink thrown in. And that's, you know, that's okay if you're in academia, if you're actually interested in the pure maths of it. But it's terrible when you actually want to learn it applied to something like, you know, rigging or tool development or stuff like that. So with all of that said, that is basically what I want to do with this. Dumbest things and, you know, de-escalate things that look software specific to their first principles, and then escalate whatever is required in terms of knowledge, be it maths, you know, and if we get a few seasons in and we start doing interesting things like deforming creatures, then that bleeds all the way out and goes into anatomy and kinesiology and that kind of things. So this is not strictly, it's not actually a development stream. Development just happens to be an important part of designing creatures and rigs and providing tools. So next thing will be, what is a first principle? There's 2 things I consider pretty important in rigging, or rather that I'd say people should be rigging by, which is rig by first principles, and what I do, and that is a choice, and it's the one that I'm going to peddle, is what we started calling a while ago component-based functional. That goes into encapsulation, a number of other things. We will explain those piecemeal as they come. But a first principle, for those who are not familiar with it, is actually a very simple concept. It's something that you basically either assume to be true, it's something that you predicate everything else on. In maths, very often there are axioms like, you cannot start something unless you have a ground truth of sorts that you can base your following thinking on. Now, the thing with first principles, for them to work in a context like this, is that they have to be simple, they have to be atomic, they have to be pretty bulletproof. And we're not going strictly by just the math definition of first principles as much as by the idea of having principles. So as far as I'm concerned, you know, nothing should ever drop the performance of a rig unless it's absolutely necessary. And very often you have trade-offs like features versus performance. Obviously, if possible, you want to try and find ways to do both, and very often it's possible. But some other times it's important to be able to analyze features and animator requests and things like that so that you do not lose performance. Sometimes animators know what they want. Some other times you actually know better. But it's your job to make it look absolutely kick-ass so that people will buy into it instead of resisting it because, you know, it was badly presented or it was low. So, and in my experience, if anything is low and, you know, even as a prototype is presented slow and clunky, it just does not get embraced. Even if it's a great idea, it gets kneecapped before it ever reaches production. So, you know, making things stable in terms of transforms, making things stable in terms of performance, in terms of actual application, making things stable in terms of like whatever temporal functions you have. And if that sounds alien, don't worry yet. It's something that we are going to get into. And ensuring that everything is as fast as you can possibly get it within, you know, the time limits you have at hand. Those are pretty much all the things I care about in how you go about rigging something, how you go about introducing features in a rig or in a tool. As far as the rig organization itself is going to go, component-based functional, like you can ignore the functional part for now. It's largely irrelevant for now. But the component-based one is pretty important. Now, let's talk for a moment. So with this big spiel out of the way, I don't know for how long I've been rambling, probably 10 minutes. I reckon we can actually get into doing something about this. So as far as the stream goes, you're going to see a few things. You're going to see, you know, whatever 3D application we use. When you do it at home, it's going to be whatever you choose to use. I'm going to use Maya 2017 update 3. You're not constrained to using that at all. There is a number of solid pieces of software out there. The reason why I chose to use Maya is basically twofold. One is widely used professionally as a rigging platform in a lot of industries. And I think to do something that is relatable because a lot of people already know it and is applicable if you're looking for a job eventually, if you don't have one, or if you want to keep yours, statistically, it's likely to be very useful. Now, the other thing that I actually quite like that they started doing with Maya 2016, and I've had a number of talks privately, you know, more openly and all of that about these with Autodesk developers as well as with users. And I think at some point I even did a lecture, whatever you want to call it, for Rigging Dojo. Is in 2016 they introduced parallel evaluation. Not going to go too deep into that right now. In fact, not going to go into it at all. But it is very, very important for performance. And when we'll get into actual performance and how it relates to hardware architecture and things like that, it is paramount to me that you have something similar at hand to experiment with. Now, the other thing I do a lot, and anybody that has worked anywhere near me is probably aware of it, I always leave behind a trail of scribble whiteboards and blackboards and whatever I can get my hands on. So this is something that's going to happen on stream as well a lot. We're visual creatures. There's a very large chunk of your brain that is actually used to process visual informations and transform them into thoughts that can actually be processed by the rest of your brain. There is always going to be something on screen for me for things to actually get explained, and I think that will help a lot. So with that said, and introducing what I guess is our first principle, naming conventions. Let's start with that. You know, we have a Maya scene. This is not the naming convention we're going to use. You can ignore it. We need to find how we want to sort things out into the scene. And naming conventions are a bit of a funny thing, as in I have sometimes heard, and I'm quoting literally here, they're a matter of opinion. And it's like, no, just no. And this was actually, I heard this from two people, and they were actually very well clued in professionals. They did great work and all of that. I don't know why they came about these stance, but anyway. So yes, there is some matter of personal preference to it, but, and this is where we go back to first principles. The idea of a first principle, one that is applicable and useful, is that it has to be objective, which is one of the reasons why I like performance, because it's measurable. There's a question in chat. Are the deformers in 2017 GPU driven? Yes. Most of them are. There's more and more every version. 2016 only had like 3 or 4 maybe, and there's been more every version. So, and yes, GPU deformation is actually pretty important to me, but it's probably a couple seasons away, if not 3. So, naming conventions, not a matter of opinion. Now, what are the first principles of naming conventions? Like, the first thing you want to do for something like that is isolate the things you know. So, one of them is that if you have names, they're going to be strings. So whenever you're designing anything, and designing a naming convention is pretty much system design of a sort, or arguably data design, interface design, whichever, depending on what angle you actually look at it. Now, we know they're going to be strings. They're going to be used as strings, and that is the end of it. There's nothing else really to the naming convention once it's deployed and it's hard data. So whenever you design something, marshal all the objective facts that you can actually find about that subject. Without going too deep, it's not something that we want to de-escalate and re-escalate right now. Strings on CPUs are tendentially fairly slow. String comparisons and stuff like that can be pretty painful. So if you have something like this, and you have somewhere else, you have an incognito string that you actually want to check against that one, the only way for your for the libraries you're using or whatever you're using in the CPU under that to know if this string that you have is equal to that string is to go and character by character, byte by byte, look at whether all of it is the same. So I will first compare one piece, and if it's true, move on to the next, and so on. And the earliest you fail, the better off you are. So strings should be something, whatever your naming convention is, that can, on comparisons, fail early, which means don't have long tokens at the beginning. So another thing, if you've never heard of tokens, they're basically discrete components of, usually they're used for strings. So they're discrete components of something larger. Now, if my naming convention, and this is actually what I am going to use, is going to be something like that, which is the component, the side of the component, some warble about what the object might contain, and then some extension that is type E. Okay, I have just somehow managed to disable the pen. That is brilliant. Probably by color. Yeah. So you normally choose a separator, we'll use underscore, and then each piece between separators is a token. That's pretty much all it is. It's a discrete element within the entire thing that you're looking at. So here's what we're interested in. Make sure to fail early that the most interesting thing is first. The thing that you compare against the most, if comparing the strings is your main, is basically the thing you want to do the most often, is always available first. Now, same for the second part. If you have deep comparisons, make sure that the second most commonly checked thing is available pretty early. If they have the same importance, other parameters come into play. We're going to leave some space in the middle, and then we're going to leave the type at the end. So the type is something that maybe you want to check very often. So here's something interesting about anything that is string naming conventions and so on. Your first edge, so your early edge is something which is where you begin, basically. Pretty much 90% of the planet goes left to right, is your fastest part of any string, is your fastest part of anything that is names and so on. Now, this bit in the middle, which could contain anything, is actually the slowest. The second fastest part is your late edge. And that is because at any given time, you basically know, usually at least, the length of the whole thing. So checking for something at the beginning, fastest way, absolutely. But checking for something that you know to be at the end, up to the first token when you walk it in this direction, is actually probably the second fastest thing you can do. So, and that is, talking about first principles and, you know, things that should govern how you design things, that is important to know. This actually applies all over the place. Now, anyway, now this applies all over the place, and it's we're gonna get into it when we start doing a bit of calculus and stuff like that. But if this was a domain, there are many cases where you have a domain that is linear. The edges of the domain are faster than the middle of the domain. So with all of that said, now the other thing is, okay, how do you decide, you know, lowercase, uppercase? For the sake of doing it, we're gonna, you know, just choosing something, and sometimes your principles have got to be like that. We're gonna choose that we're gonna use lower camel case. So if you don't know what camel casing is, it's basically something where all the words are concatenated without spaces or separators, and every new word is started with an uppercase letter. Upper camel case means every single beginning of every word is going to be with an uppercase. Lower camel case starts with lowercase and then ups only the following words. I prefer it. There's a number of reasons for that, but this is something that you might almost argue is unpinnable. Now, the second important thing is, where do you choose to break that convention? Where do you choose to capitalize? So if we're going to say that we're going to do, for our tokens, we're going to have a component token. And then the second most important thing we care about is the side of that token. Then we have a warble. We don't care about what's in there just yet. And then we have a type. Now, if we strictly adhere to lower camel case, then this side should actually have to be, and let's say we have middle, left, and right, and no, there's no up and down and stuff like that. We'll get into that eventually when we start encountering, when we start encountering that. Then you would have, you know, right, middle, and left in uppercase. If we went for lowercase, the problem you have is that you end up with characters that are a lot harder to read. And the main thing, and I need to set my tablet because right now I'm stretching everything, but I hope this is still readable. The main issue, and this is something that you can find around, is there's a rule that says when you have L in isolation, try to never use L in isolation, because in a lot of fonts you can't tell it apart from an I, from a capital I, and that is very true, and there's a number of places where that comes into play. So we choose to break this convention, and we choose to make this token special, and we go, okay, this is going to be lower camel case. So if I'm doing a leg, you know, this is going to be simply leg. The side is going to be whatever side we have, so we might say that's the right side, warble. And for the type, now let's get into this for a second. This is where you have to start going cross-discipline. And I'll go on a mini tangent for just 1 minute, which is, in rigging, it seems that we think that we're all super special little diamonds. And a lot of people think that rigging is its own thing. That it's special, and I've heard it many times. And in a way, it's true that rigging and animation tool development has kind of come up in odd ways. It's always been an odd evolution. It's one of the things that straddles many points in the pipe. It is a mix of, you know, creative and extremely technical, which I don't think needs separating. You might argue whether it's artistic or not, but it is not special. I'm sorry if that's a surprise to anybody. It is based on nothing else than a number of other disciplines that already exist. So a lot of this stuff, when you look at naming, what you're interested in looking at what programming conventions usually go about. Now, there's one that's called Hungarian that is, it's become infamous from some Microsoft programming book for Visual C ages ago. And that was system Hungarians, which was saying if you have, you know, a variable that is of type integer, then you should call it by starting with int and then the name of the variable. That is generally a terrible idea in a typed language. Now you could argue that maybe in something that is that isn't typed like, or is softly typed like Python, it might be a better idea. I will still argue that's a terrible idea. This prepending the type of something, making the implicit type of something part of the name, to me it's a terrible idea. And I've actually seen this done. So I've seen people, sometimes even starting the string with that, starting the name with that, going like at the end of something, loc for locator. So here's an interesting thing. If I'm in Maya, and you'll hear the same exact argument when you talk about programming, and I create a locator, the icon is already telling me that it's a locator. Thank you very much. Now, what is even worse is that if you actually show the shapes for that locator, the thing that people will call a locator is actually not even a locator, it's just a group, it's just a transform, and the shape underneath, it's the one that makes it a locator. Programmatically, same thing. If you're in Maya, you want to know is something of a type locator, you have a pretty fast way to do it. Please do not do that. There is absolutely no point to put in the implicit atomic type of something in the name. Now, the type of something meant in terms of how you intend to use it, however, that I'm a big fan of, and I consider it very important, which is for me, it often ends on the second most important part of the tokenization, which is the late edge. And let me explain that. Now, I have a naming convention that I've been using for a long time. And it's now like the word is riddled with this thing because a lot of people like came and worked with me in one shop or another, liked it and brought it somewhere else. I've never used any others. I found others in several places I've worked for, and I tend to like the one I use better than anything else I've seen in so far. And I'm specifically saying I like it better. I've seen some good ones. This is something that works for me. So if you have a bunch of things in your scene, and I hope these reads are right. Maya is not super friendly to high DPI. Now, and you have a bunch of groups, and you know, if you adopted something like System Hungarian, and these can have any name, you know, it might be the rig for your component. So we go like, okay, this is Will, it's in the middle, and this is gonna be whatever we're using to rig the fork, and ignore this HRC for a second. Then there's something underneath, which is where we actually put some parts of the fork. Then we prepend things with the name of the component and the subname. The bit in the middle is a warble, you don't need to worry about it. This will be an example of something that I've done for a long time in my naming convention. So, and this is what I consider to be somewhat important in a way. Now, these are all groups. However, how you choose to use those groups is very different. And that is what I would consider the type. So HRC, which you can actually call, like I've seen it called org in some places. I've seen it missing in some places. I've seen it as GRP in some places, which to me is bad because it goes back to System Hungarian. This is basically just saying I am using these purely to organize the hierarchy. I do not and we're going to define the standards of how these things are used, and the naming convention just represents the convention that we choose to have for the hierarchy. But this is basically saying this is not gonna have any transforms on it. All this does is it's an interrupt in the outliner, so you can select the hierarchy, something like that. Now, if something is used purely for the sake of transforming things, regardless of the shape that's underneath, normally I will call that an SRT. SRT, yeah, some people in chat are saying exercise for life. Yes, XSI called them SRT, but it actually comes from long before then. That's scaling rotation translation. So it means that there is something that is more than a row matrix. It's intended to represent, these values, so that this thing is the thing that programmatically or not is actually going to be moved around. Now, there's many reasons, and I'm not going to go into them just yet, why I dislike pivots. They got better in 2017 actually, but it's gonna make your life a lot harder if you make abundant use of Maya's pivots. They're not flawed per se, they're actually pretty well implemented, but they introduce transforms at an object level, like within an object, at an attribute level, instead of aiming them at the object level. That makes your life so much harder whenever you have to write an API or you have to manage rigs. So if I want to zero out the transform of something, normally I will have, and this is super common, you've heard it, like probably done it for a number of years yourself, I will normally have something above it, and I've seen people calling them zero nulls or zero transforms, whatever. To me, this is buffer. This is basically saying the default position that whatever is underneath should start pivoting from the 0 for these, the 0 in the word or in this hierarchy for the object underneath is going to be this. So to me, these are actually interesting types because what I can ask Maya about these objects is very little. It's all Maya is going to tell me, sure, it's a DAG node and sure, it's a transform capable. It might even tell me, if I ask for it, whether it's locked or not and whether it has a pivot or not and stuff like that. But it will not tell me what my intentions were for its use when I've created it. So to me, that's basically, in a way, this is Hungarian. It's end Hungarian, but it's not system Hungarian, which is the bad one. You can read more about it if you wish, but at this point, I think this has been belabored enough. So, super small tangent. One of the reasons why the stream is important to me is that, and why I'm not just doing some YouTube videos and monetizing them, is that to me, the interaction with the community is by far the most important thing. So if you guys in chat want to ask for anything, if you want to shoot the breeze in it, feel free to keep the chat busy. Feel free to ask questions. Anybody who's been, at my lectures at work or somewhere else knows that normally every like 10-15 minutes, I actually hope for interaction with the chat. It makes a huge difference to be able to steer the conversation and steer what you're teaching based on what the general feel of people that are actually listening about what you're saying so far is. So mini tangents done. I'm gonna ramble on with these for a little bit longer. Now, so we have a bunch of rules. So did you say what HRC was? Yes, HRC is literally just to isolate the hierarchy. Now, do I use inherit, transform or not and things like that? It depends. So, sorry, let me lower the mic for a sec. Sorry, my voice was dropping a little bit. So, it's what you choose to make of it. In my case, HRC for me should never be transformed. Now, I don't want this to be something where you go, okay, this is, the ultimate naming convention, just implement it. In fact, I think that you should implement your own. But for everything that we do, I would avoid, chasing me step by step and trying to do exactly the same. You're usually going to learn a lot more by doing your own thing. Now, if you like the naming convention, use it. I mean, this was what I thought was a good example of starting to show how something that is often ignored and very, very simple actually has very strong first principles. So, do you prefer one letter side or two letter side naming, RTLF instead of RNL? So it's really not that big of a deal. And even when it comes to performance, like you can be principled about it, overly principled about it. The shorter something is, the faster it is going to be to deal with it. So if all you intend to describe is, right, left, and middle, I mean, there is not a reason I can think of why I would want two letters. To me, having one letter for something like this actually makes it visually, once it has two underscores by the side, it makes it visually a lot more intuitive, a lot more of a first glance thing, which is what you want from a strong capitalization like that. And the reason why we don't lowercase it, otherwise the L becomes the I squiggle. But I would say I prefer single letter. It's faster to compare. To me, it has more visual impact. That said, it really doesn't make that much difference. If you find that two letters works better and you want to make an argument for, one day I'm actually going to do not sides, I'm actually going to do octants. So you might want, top left 4, top left rear, and so on. Do whatever you want. It depends how you want to organize things. If you want to organize things in quadrants, then you need to describe 1, 2, 3, 4 quadrants. If you want to describe things as sides, all you have to do is describe 2, or when you're fuzzy, which is middle. So you basically in both states at the same time or neither state. If you actually had to do octants, have a sphere, and this is possibly the worst sphere ever done on stream, but you basically have to describe 8 sectors that you want to deal with. So, you know, if you have 8 sectors, it's whatever works for you. Having things in rigs as in code is definitely one of the perennial problem. Yeah, it's largely about having an agreement. It's only a problem if you make it one. It's hard to make people agree. That's why it's tough. If you're on your own at home, like, experiment and find something that works for you. Now, the other thing is, and we're gonna get more into this, but the other thing is, it's important that you define as much as you can about something like this. And I'm gonna catch up to the questions right after this. So another thing is separators. How do you choose one? How many do you allow? In this case, we're using underscores. And again, find as many objective facts as you can about what you're designing. In this case, sorry. In this case, we're using Maya, which pretty much doesn't allow anything that is an underscore other than alphanumeric. So we're going to say the separator is always going to be an underscore. You could make a case, like now in XSI example, you could actually use a dash as well. So you could, you know, if you wanted to distinguish inside, let me get something with a bit more headroom. So if you were in XSI and your warble here, you know, you wanted to go, okay, I have a leg, it's leg right, and I want 2 HRCs. One is going to be interrupting the hierarchy for the IK, and the other is going to be interrupting the hierarchy for the FK. Then you go, okay, they're both HRC. In here, you could choose to go, this is, and maybe you have foot and leg and subcomponents and sorts like that. In XSI, you could have chosen to do something like leg dash. So you could do leg dash IK and leg dash FK. In Maya, you cannot. Well, at least I don't think you can. So you're limited to 1 underscore. Now, if for some reason you want your tokenization, which is largely a string parsing manual, you know, we'll do a lot of it. But it basically means, you know, find this specific token in the string. So you have a monolithic string, find that token so that you can re-separate like this. Now, not having something like dashes or other special characters means that it's pretty hard to separate things. You can only separate them through camel casing, which means some people, I don't do it, but you know, you could make a strong argument for it, might say, okay, look, my token for, sorry, my separator for the tokens is going to be a double underscore. So I'm only going to separate the tokens if I find the double underscore. If I find a single one, I'm actually going to consider it part of these tokens, so that you could basically gain yourself back a separator for cases like that, where you want your warble token to actually have some sort of deeper distinction than just upper camel case or lower camel case, whatever casing you use. I'm not going to use it. I've tried on and off, and I just don't find. I find that it's easy enough once you have good tokenization and a good naming convention to have things organized the way you want. And you don't want everything to be predicated on the naming convention. So let me catch up to the questions for a sec. Are Maya's namespace still a thing? I've heard a lot of people saying don't use namespaces. So namespaces can be painful. They can be very, very painful. We will use them, and we will use them thoroughly. I don't think you can actually use Maya to its full extent in a pipeline environment without namespacing. They're under the hood, they're actually the simplest thing ever, and they're very, very easy to manage programmatically. The only big problem with namespaces is that there's a bunch of bugs and half-implemented tools laying around, and this is true for both native Maya stuff and plugins that people use. They just don't handle namespaces, which is a crying shame. But yes, they are a thing, and yes, I will be using them pretty heavily. So moving on with this now. Naming conventions again. Sorry, I have to collect my thoughts for a second. We were saying the important thing. So we got type out of the way. You know, you can even mess with these a lot. Like you can choose to have 3 or 4 different types that you're always going to carry because they're the foundation of your rig, of your rigging methodology, or how you sort the scene out. And then you can choose to occasionally do something that is very arbitrary. Now, another couple things I do not do is and this, I think this comes from all the way back in Windows when you could only, in DOS, you could only have, I think, 12 character names or 8 character names and 3 character extensions. People jump through hoops that were set on fire while a crowd throws knives at them to get all of their stuff into 3 letters. I don't know if you're one of those people that does it. I don't know why you do that to yourself. I mean, seriously, if you need an extension to be, and let me get Maya for a sec again. If you need an extension to be 7 character, 8 character, 10 characters, it's at the end of stuff. And it's largely only really informative for when you're looking at sorting things out. It's not something that the animator will see or care about a lot. Don't do that to yourself. Don't limit yourself to 3 characters. Then from here, you're free to do whatever you want. But there's a lot of stuff like that that's still lying around. I find there's a lot of myths. There's a lot of legends about how some things are and how they should be, and some of them are like super dated. Now, going back to our naming convention, so we found a few interesting things. Early edge is important. Second most important thing should go on the second part of your early edge. Don't keep this token too long if you want fast comparison. Now, I don't want to overstate that, because unless you're like literally going for a bazillion strings, it doesn't make a ton of difference if this is 3, 7, or even 15 letters. Second most important thing, when you walk the string from the other end, you can find something, and this leaves you with your warble in the middle, which you can make whatever use of you want. Now, this goes back to why I don't feel I need the double separator to have another thing in here, because the number of tokens is also important. So if this is my 0 token, so this is always the first token, 0 counting, computer science and stuff. This is my second token, it's always going to be 1. I always have access to this one by going -1. So it doesn't matter how many underscores I have in the warble. I am not interested in this being, this being number 2 and this being number 3. I'm just not. I'm interested in this being -1. Even conceptually, we decided we'll walk from the other direction, so it's -1. Which means you can use whatever you want. You can use underscores in your warble in the middle. It does not make a difference. Now, moving on. Other things that naming conventions are important for, and hopefully this is the last of it, unless people have questions that come up, because half an hour of naming conventions and going is, I think, enough of it. Now, I do not like predicating things on the naming convention, and we will see that. It's probably a while away, and it's largely got to do with graph management, a little bit of graph theory, API development and so on. But I don't want the fact that this is called SRT buffer to be indicative of what it will do. If I write an API that builds rigs, I do not want the name to have an effect on what actions are taken on it. The name to me is always the rendering of what the purpose in the API, or if you're doing things by hand, which we're going to do a lot, your mind is. This is just representation. You should not struggle to manage it, and it should not be king of the hill. With that said, things occasionally break. When you're at the beginning of a new pipeline, God knows I started many pipelines, things break often as you go through tests. The other use for a solid naming convention is if something has gone to crap, it has to allow you to reverse engineer as much information as possible. So, and what that means is, again, the naming convention alone should not be responsible for it. So your hierarchy can help a lot. So an example, if you have an SRT and it's under an SRT buffer, and this stuff as 0, you could probably assume that this SRT buffer is correct. So combining things also helps. Like never look at just the atomic element. Combining and giving context to what you're doing is pretty important. But another use for naming conventions is reverse engineering a scene that has gone wrong. So again, the stronger it is, the more consistent and the more recurring items you have in it, the better. So don't make the warble, the bit in the middle, king of anything, but do keep things consistent for as long as you can. So what that means is that, and this is probably going to be faster if we do it here, if we have a rig like this, I'm going to say, okay, this is my component is will m, and we're going to go through components later on. And I'm choosing that this thing that I'm representing with this hierarchy, which you can only see from manipulators, possibly not the best of ideas. is gonna have this is gonna represent the fork. Not a great idea. Maybe the fork shouldn't be part of the wheel, but let's ignore it for a second. Let's say that the other component we have is gonna be the pedals, which might be a better fit for a wheel component, arguably. Now that will be wheel M, pedals, again, HRC if you want it, it's just to organize things. Don't feel you have to put things in, you can always go minimal and add things later. Now, if for some reason, I know that something is word space, so don't always buffer everything. I mean, I don't always buffer everything, you can do whatever the hell you want. But here's a thought. So maybe, and this is obviously not applicable to something that rigs pedals, maybe I don't care for these things to have a buffer. Maybe I am stating that these are actually always going to be in word space. In that case, it's a pretty good idea to not give them a buffer so that whenever you move them around, you know, by the graph or by hand or whatever, you know that the local transform, the one that is in SRT, is actually the same of your word transform. And this is what I was saying. Like, your hierarchy coupled with your naming convention can actually express a lot. If my build script for these, or if my build metadata for these, had for some reason broken, and I needed to reverse engineer things, if everything always had a buffer, then you know you might as well use pivots. Well, almost. There's a number of pain points with those, but if some things have one and some things don't, and that is purposeful, if you've done it intentionally and if that it describes something, it is more that you can reverse engineer. Now, the other things you can do is obviously, you know, if something is an SRT, maybe you don't want to have translate, rotate, scale locked in a node like that. Whereas if something is an HRC, maybe your convention or your operating convention is, oh look, all of these actually gets hard lock and hidden. Now, sorry, trying to marshal my thoughts again. So that is the second part where you want, as you design any convention, remember talking about designing, you should go out and try and design your own, don't necessarily use this one. That's the exercise in something like this. Make sure that you find things where it's useful and that you implement, that you develop whatever you're doing against those. So another point of naming conventions, and this is something that you normally have to do by census. You know, we say, okay, it's good to disambiguate, it's good for programmatically comparing things. So we want to obey some rules that make comparing strings as fast as we possibly can. It's good to desume interesting things at a glance. The other thing that is incredibly important in one, which might add sub rules or might drive you to to scramble it a little bit, is how does it read when the user uses it. Now, we're going to get into how to manage the outliners. There's things that are pretty useful that I like with containers, but I will not suggest using containers before 2017. There's a lot of pain points that have been addressed between 2016 and 2017, and I will definitely not use them before 2016. Anyway, you want the outliner and the graph editor to be somewhat useful. So if you have something like this, and something is actually animatable, let me get a curve and let's pretend that this is, you know, some sort of control. So this was my pedals control. This is what the animator would actually use. And so let's say that we will call that will end. This is for the sub of pedals, and I will probably also make, well, normally I make control and SRT exclusive. So an SRT to me is something that is controlled procedurally, and a control is something that is controlled manually. So let's say that we zero these out and we turn these, we've changed our mind on something that was programmatic, only programmatically manages, become manually managed. We rename this to a buffer. You can choose to do whatever you want with shapes. Again, it's something that I find there's a lot of legends around it about what is good and what is not. Like, there's some things like, oh, don't have multiple shapes. They will burn your house and kill your dog. I actually have used plenty of things with multiple shapes underneath. You do have to manage things. It depends on how much you customize and what bits of Maya or plugins that you use break with it. You could choose to separate and use your own, or you can choose to actually, you know, exceptionally handle them and let Maya do its thing, which is always capitalizing the S of shape and adding it as a postfix to everything that is in there. So suffix in this case, actually, not postfix. Now, with that said, so this is something that you give the animators. Don't go absolutely nuts with the descriptivity of your names, and feel free to diverge, compress, and decompress things so that they actually get something that is contained enough. Because the outliner, I don't know if it'll get me anything if I open it like that. Sorry, not the outliner. The graph editor actually often comes up nasty small on this side, and most people keep it at default size. So that's another thing you have to keep in mind. Are your animators comfortable with getting the information they want at a glance with this? Now, again, these I've had pretty good success with. Last couple of things, some people might say, I'll put the left side token before the component token, sorry, the side token before the actual component token, or whatever you consider the most relevant thing. Personally, I think that's terrible, but you might want to do things otherwise. The main issue I have with that is that it's very rare that I want to see, if something is sorted alphabetically, that I want to see everything that is the left side, and then everything that is the middle side, and then everything that is the right side sorted like that. I really have no use for it. I've never found a use for it. Mirroring scripts and stuff like that, where the side matters, they tend to be relatively slow. Even if you make them very fast, they're still a run once thing. They don't constantly run in real time. That it is important that you can find left to right immediately. And anyway, almost always when you're doing left to right mapping, mirroring scripts and so on, you almost always have to match the law and just swap this one anyway. So I don't advise that. I don't like it, but you're free to do it. If you find a good argument, if you find that it works for you, that's great. Now, again, last thing, I find that this works right for the animators, because almost always they're interested in knowing, oh, look, am I using, if they select something that's gone off screen in the rig that is, somewhere a million miles away from the rig, usually they want to know, okay, what is this thing that I've just selected in viewport? Is it a leg? Is it something else? Without framing around in the outliner, which, unless it's very tightly managed, is usually a ton of objects for a complex rig. So this also works. It also means make these things somewhat descriptive. And this is where the warble mostly comes into place. And this is why I often do things like this, having IK and FK. Talk to your animators. If you animate stuff yourself, it depends on the qualities of the rig. Now, some people want naming conventions where basically they spec them out so that every single object you look at in a shot is guaranteed to be nameable by this Uber naming convention. I don't like it a lot. I don't think it's actually quite doable, because normally every production is slightly different. Every rig becomes, slightly different. So I like the warble to be pretty free, and I would say that animators being able to read it and use it is pretty important. Now, I reckon that for now that is enough for naming conventions. So if the chat has something they want to know about all of these, let me know. I'll give it a minute. I'm gonna lower the mic and drink some water. Otherwise, we're gonna move on. All right. So, all right. Seems that it was either so blindingly amazing that nobody has questions. Oh yeah, somebody asked. That's actually a good question. What about numbers, letters, about similar items, e.g. fingers? So it's up to you, and that's why I don't like naming conventions that are too constrained. Something that I have been doing. So if you're doing fingers, and we're gonna go into more when it comes to components, but what distinguishes a finger from another for you? Now, the component for the finger, like leg left and right, it's pretty easy. Most things like the spine and the neck and the head and your master controls, unless it's a weird creature, are gonna be just middle. Now, when you have things like fingers and so on, they tend to be at the end of something, and that is true for toes and all of that. So I like them to be sided like the item that they're under, and that's one of the things that I don't like, things that are more than two-sided. It's not that I don't like them, I don't find them supremely useful. So if you go down to the hand level, then the distinction you have to make is basically between these items. And to me, it depends on implementation a lot. So if your fingers, and that is why I kind of need to get into components more to properly explain this, but if your component is basically going to be the hand plus its fingers, and if that sounds silly, it actually is not. There are cases where you might want to do it, especially if you need IK fingers that affect backwards through the palm, which for some commercial rigs where you have a lot of hand replacement is actually super useful. Then you need to respect the component naming, which means you will have hand, side, whatever, and then you have to use the warble to say, well, this is a finger. And so you will have finger, and then you can use, I don't use letters because you run out of letters and they don't stand out. And if you capitalize it, it kind of competes for your visual mental space relationship with whatever is close to it. So, but there's not a strong neurological argument for a choice like that. So it's pretty rare I find that you have more than 99 or something. For component stuff, I often, for things that are in scene, I often tend to use one numbering, so not starting from 00, and I will leave the 00 for setup items if I really need it. And I usually double pad like that. Now that is, so they can kind of grow fairly long, because then you might have, phalanx, and you might not want to do distal and all of that, so you might choose to go, phalanx 01. Again, this is where I will say common sense and things that are useful. This is your warble, and this is why I like the warble to be pretty free. Common sense takes precedence. If you know that, like, the phalanx does not, like, this, unless you're doing some really weird ass creature, the phalanx is not going to have more than 3 things, right? Your fingers, unless you're doing somebody that's been in an accident, there's going to be 10 of them. If you start from 1, it means that you need 2 digits. It is pretty unlikely that you're going to need 100 fingers. So I will name something like this. Now the other is, if component-wise these are actually separated, if you have a component that's called fingers, then you kind of fall back into this. Just the only token that will change is this. If all your fingers are merged, and if that sounds silly, it's not, because there are components where the fingers are important to each other, rigs where they're important to each other, especially for ground contact or, again, hand replacement in commercials, where you want that kind of behavior and you want the fingers to repel each other or things like that. So there are cases where you will have to give up the component token. Now, if it's the classic cartooning rig, if it's, feature animation, like 99% of the time, to me, this stuff ends up being separate fingers, and what you get for me is, and this is something that I reckon you want to figure out with your animators, is, you either do finger 1, L, and then your warble, and your warble might actually contain index or thumb or whatever, or you do, finger, thumb, or if you care about sorting, you could even do something like finger 01. Common sense definitely trumps being unretentive about your naming convention. So if you put the fingers under the hand, will this make the hand the component? Okay, so there's a bunch of questions that are starting to encroach the component realm, which is good. So okay, there's 2 questions. One is largely about components, so we'll get into that soon enough. Now, and actually components is what I want to do for pretty much all of tomorrow's stream, and I maybe see a little bit more of mine and less of the Blackboard. So if most of your search and fixing will be handled by scripts, wouldn't storing some sort of meta into the node be a better option, assuming Maya doesn't need to have all this kind of stuff? It's one of those questions where you go, it depends. Yes, do not store info in the name. If I've given you the impression that this is actual useful info, as in that is king of anything, don't do it. That's why I was saying, if the scene is broken and you need to reverse engineer things, and the scene being broken often is the metadata that you attach to nodes being broken or being inconsistent, It's that double check kind of system. Have redundancy of some sorts. Have as much redundancy that doesn't cost you performance as possible. And if that redundancy is built into your standards and into your designs and all of that, you're usually much better off. So that is actually a pretty good question. And I guess the point about that is very often your metadata breaks. Well, it depends on your pipeline. It doesn't break that often where I work these days, luckily, as in years, but that's because it's taken years to develop it. So if you add, for whatever reason, something that identified this object, whatever it is that you're pointing at, as the finger, and you were relying on the metadata for it, and the metadata go absolutely garbled or blasted away because some, and it's insane, and some, overly entrepreneuring animators started writing horrible scripts that like blast away attributes that he thought were unconnected. This is what will fix your metadata, or it gives you a chance if you interpolate enough to fix the metadata. Does that make sense? So I will assume it does. Ask more if it doesn't, and move on a little bit. Now, components, I will do a lot of it tomorrow, but let me just introduce them. I'm gonna go on for about another 50 minutes because I promised that to the internets yesterday. The internet's fulfilled its part of the bargain. Now I have to fulfill mine. And then I'm gonna take like 50 minutes of pure Q&A. So the component thing needs a lot of explaining, a lot of time to do right, but it's purely organizational as far as things start, let's say. And in this case, it will be, let me unhide, what am I doing? This one. Let me unhide this. So, and let me delete this crap. Now, the first thing about components is they basically are for you to organize the rig properly, but there's a bit more to them than that, and we need a little bit of graph theory. There's a little bit of graph theory behind these, and then it escalates to the atomic graph theory side of things, which is Maya's graph and so on. Now, what you want to do, and this is where I really love mischief. So, if I can actually, there you go. So one of the things you want to do with components is first is have some logical ordering of things. So let's say that we say that one of the components we want to use, we want to rationalize is the will. We know the will is always going to be manageable as a discrete entity. So we go, okay, this is going to be a component. I don't like lists, but there's some stuff where you want to make lists. And componentizing a rig, probably a good idea to do it. Now, let's say that the fork is another component that makes sense. And I don't have pedals on this geo. I will add them later, I promise. If this is even a fork. I don't know if it's a unicycle. Is it a fork or is it a frame? I mean, is it both? It's a fork frame. So let's say we want to isolate that. We think it's good enough to be isolated. And then in here, we actually have pedals. And yes, that is amazing. And we're going to say, that's going to be another one. So here's a couple of things you have to figure out, basically. One of the things you want to do is interface first, and we will get that. That is very, very dear to my heart. We will get that into excruciating detail many, many, many times over. Fork style frame, brilliant. So it's a fork frame. It's a whatever. You guys get to name it, and I will actually name the component like that. Now, these components are also they're supposed to help you to rationalize parts and to split things in your naming convention. They have a number of there's a number of things you want from them, but you also have evaluation graph concerns with something like that. And I love that somebody actually went and needed to find the answer for what that is called. I expected nothing less from you guys. So the pedals, in example, if you're doing a bike, sure, unless you're doing something really weird, the pedals are usually connected in a device like this. So is that one component or is it two components? And you could go either way, and we'll get into that. Now, if the pedals are always connected to the wheels, if you don't have something where you can backpedal, in this case, I think a unicycle is always direct traction. I don't think you can spin empty, then there's no chains with a drop. All right. There's someone saying graph touching and graph theory going to be gold. That is someone I know and who has actually written a graph system after I gave him a major headache about graphs. So good to see you, man. Now, this is where you go. There's an evaluation part of it, and it's kind of hard for me to like only sketch these out without going into more depth, but we can try. So there's dependencies. Now, do you want the pedals to actually, I have to switch the colors all the time, don't I? To actually affect the wheel? And do you want the fork to affect both? Or do you want it to be the other way around? Like, because this could be pretty awkward, like if you get it wrong. And often you find that you need to reshuffle the components. So if the fork, actually no, so, well, the person that looked up on Wikipedia what it's called has said frake, so that's now a frake. And if you're dyslexic, this is going to be a riot to write. Now, if the fork is going to affect the wheel, so as the fork moves around and the wheel moves around with it, and we make it spin in the rig or something fancy like that, and the pedals were actually supposed to be driving the wheel, this doesn't work out. So what you have to do in a case like this, does Mischief actually support the eraser? Yes, this is brilliant. If you don't know, the app I'm using is Mischief. It's amazing for blackboarding. There's also something that was done, the Handmade Hero uses, that was done as a handmade project that is called Milton, that I think works pretty well. I very, very strongly recommend that you get either, whether you can afford, Mischief or you want a freebie. They're amazing to take notes and do blackboarding. They're infinite canvas system. Anyway, then you have to decide, what order you want things to proceed in. And now, this is something that I have actually seen, when people don't make a strong case for components having an identity and being encapsulated, what you end up with is that the hierarchy in here, for something like that, like the componentization and the way things are inherited and so on, is left to the hierarchy. They're not separated, they don't have a strong identity, and then you get a ton of conflation. Like doing this reordering, if everything is intertwined and weak, becomes very, very painful. Now, even more important is that, and we will do that, that's one of the reasons why I chose a unicycle as an example, is sometimes you want directions to actually change. Depending on, well, it's a feature in the rig, you don't have to. But depending on what the animators decide to do, whether the pedals drive the wheel or the fork, the frake being moved around, spins the wheel on the ground through some sort of automation here, and then the pedals follow so that they constrain the character's feet to the pedals and drive the thing from the bottom, so drive the vehicle first, then it means that this relationship has to go one way. And you do often want both. So if you have a scenario where, you have your character on a unicycle going around, and it's a wide shot and the unicycle is cruising through the shot, normally what you find is that animators will want to drive the unicycle, have the wheel spinning being automated maybe, the pedals following the wheels, and the character on top of it will need to be constrained to those pedals. So that, they get from IK, they get free pedaling basically. Some other times, if you see, copyright strikes and all of that, I don't want to pull up videos, but if you see videos of people doing stupid things to unicycles, a lot of unicycle technique is like going back and forth by balancing the pedals like that with your feet. Now for a shot like that, so if you have a static, twitchy shot like that with a lot of in-place, high-frequency movement and things like that, that relationship usually has to be inverted because people want to drive from the body. Animators will, for something like that, most animators will usually want to like get their body motion right, possibly even constrain the frake to the character so that they can drive purely from the characters. And then what they will normally want is maybe something, tools or whatever. They want to do the coarse sketching of the fit position in body space, and they want to do it in rig space and have IK do a lot of the work for them. And then some sub controls of those feet maybe gets constrained to the pedals. So you get this weird thing, but it happens all the time, these weird circularities where you go, okay, the body for the character drives the core's feet control. And when we'll do IKFK, legs, and feet and foot rolls and stuff like that, I'm going to go into detail about this because it's something that I see done wrong a lot of the times, and it's actually really tricky to do right. Then we will want the chorus pedals to be constrained to that without coming up. So we might need more complex constraint or aim or whatever. But then there's some fine control of the feet that needs to place the geometry in a way, or the heels that needs to follow the pedals. So let's say that those are the heels. And I guess you're seeing where I'm going with this. So it is important that at any given time, you can isolate these in the right way, or that if you can't, so in an example, like in this case, that kind of thing would have been, the feet probably would have these sub controls. Stream got laggy. Okay, no. Sorry, somebody was saying the stream got laggy, but Twitch thinks I'm excellent, which is great. Thank you, Twitch. And other people are saying it's fine. So I'm assuming everything is good. So the feet will actually have, a foot control of sorts. I hope you hear the narration, because if you look at the type, this is not really readable. And, a heels part of it, but your dependency with the pedals that you actually desire, well, what the animator desires, you're actually going to hate it as a rigger, but you have to deal with it, is going to be circular. And in a graph, this is pretty tricky. It's not unmanageable, but it's going to be circular. So then it becomes important that when you have this circularity, your components have the right grain of interfaces to allow for the right kind of circularity that you need. Does this make sense insofar? So this is, I'm going to go on. There's a delay with Twitch and all of that. So when I ask something, I expect the reply to be a full 10 or 15 seconds later. But if this is clear, now, this is where, and we will do a lot more of this tomorrow, but this is where you have to figure out what your first order concerns and what your principles are for component design. So a big part of it is going to be encapsulation, obviously. You want your component to encapsulate at a naming convention level. You want consistency, and most importantly, though, you want interfaces. And that is what I'm not going to say I call it interface first design, because it's actually something that was prominent in the 50s and 60s and then got somehow lost from the vernacular. And the other thing that is important is making sure that you can expose to that interface that your component has different things in one direction or the other, that you can verify that within your component there's going to be a Maya graph, and that you have a way to verify that that graph, that subgraph, hasn't gone circular on you. So that's a pretty important first order concern for any component, which is, and that's got a lot to do with the APIs that you build around them, or even just simple scripts to inspect them. But circularity is one of the trickiest thing in rigging, and yet one of the most requested. And now the other thing that you care about a lot is that, and that's always coming down to the interface, is that you can reorder these things. So you want the component to work on its own and to express clearly what it provides, and you want it to be easy enough to reorder. I'm sorry, I'm staying pretty vague with some things because this is something that I really want to go in depth in by doing actual practical examples. Now, a component should be living on its own. You should be able to alter them separately. If you talk, and this is what I'm going to show again, you don't have to do it this way, but for something like this, to me, and this is what I've seen people call broken hierarchy, which, as I said, absolutely baffles my mind because it's not broken, it works, is for a rig like that, then what I would probably have is something like, unicycle, whatever. Is that even correct? Yeah, I think so. I don't know. Somebody will correct my spelling if it's not. So if I have something like that, and then there might be stack points and stuff like that that we're not going to get into for quite a while. So let's say the components are straight up under your character or your rig or whatever it is that you call these. Then they're going to be, for me, the way I work, they're going to be separate like that. And if you want to actually have an extension, you could do something like that. Then let's say you have the wheel, and you would I'm sorry, I made a mistake. This has to be done properly. And then you would have, how do you call it, the seat? So I'm not going to get into that early on because they're deceivingly simple and actually a major pain in the ass to do, but you could even have subcomponents. So in example, you could choose that, okay, I have a pedals M component that maybe does the central part. And then under that, not broken, but rather hierarchically, and this is in terms of dependencies. I'm just using the my outliner to represent the fault, if you want. You would have something like that. And then in each of these, and I don't recommend these for the record. I'm not a fan of subcomponents early on. They're incredibly tough to deal with. I've always called that a flat hierarchy. Yeah, people have all kind of names for it. I don't have a name for it. I guess that's the point I'm trying to get across. I don't think of these things in terms of specific techniques. It's also like something like flat hierarchy is always a little bit confusing because a hierarchy cannot be flat. Otherwise, it's not a hierarchy. But I know what you're saying with that. It will be this will be, if you really wanted to give it a name, this will be a wide first hierarchy. Like you prefer width instead of going in depth. And that does exist. Like those are concepts that exist in actually graph theory, in tree management and stuff like that. If you really want to find a field that has been formalizing this for a long time and steal some terms. Show me rigging that isn't confusing. No, I can't do that. In fact, my mission is to confuse everybody to the point where they try new things. So, 12:15. I've done my 15 bonus minutes. Kiki, does this actually? I know the real names for a lot of you, but I'm not gonna use them. So deal with the nicknames. Was that actually what you were asking? Is that enough of an answer for now? I'm gonna assume the answer to that is yes. But what we're gonna do now, it's like I'm gonna call it for the mainstream. And hopefully it's not too boring to do this much blackboarding and theory. There's gonna once we get into the proper seasons, the way I see this working, there's gonna be stretches of rigging and stretches of development, and then occasionally you encounter something where you think the theory is worth elaborating on, and that becomes a lot of blackboarding. And I imagine it will be per stream. Like some streams will be very blackboarding heavy, and some streams will be maybe longer and and then some streams will may be longer, because something like doing this the scene side of the rig, like there's a lot of twiddling, there's a lot of boring stuff. It's hard to actually narrate on top of it and keep it interesting. So we'll see. But this is the way I hope it will actually work. I hope it will be well received, and it's gonna jump, and it's gonna some streams will probably be mixed. So this is where I want to start with the actual subject matter, which was it's not naming conventions per se. It's something that I wanted to establish so you guys know what I'm doing when I do it. It's more that even for something simple like that, there are interesting first principles. There are applicable rules that you can find from software development techniques, computer science in terms of like performance when you deal with strings. There are many objective, or at the very least well formalizing research parameters to so many things that you can go and fish from whenever you have to do design work. And that, I think, not doing that, not going and liberally fishing from other disciplines and trying to be a bit of a isolated insular snowflake has probably been the curse of rigging for me. Anyway, that's enough ranting. So will you save your scribbles at the end of the sessions? I can save them. I don't know why anybody would want my scribbles. Sure I can. They don't really weigh much. The issue with scribbles like these, which I'll be happy to share, don't get me wrong, is that for me blackboarding is largely it's largely about how the thinking flows as you go through these things. So I don't know how useful they are gonna be, but sure. They're also gonna be in the videos anyway. All of this is gonna be archived on YouTube. Now, hopefully OBS won't have crashed or messed up my recording, because these will be painful to redo offline. So, Yeah, sure. I'll save them. We'll see what happens. Uh, any questions? We got about 10 minutes. I'll take any questions that are remotely related to rigging. Well, even closely related to rigging, actually. So until I get any, I am gonna scroll back to the chat, see if there's anything I actually missed. There's a few interesting things that were traded here and there, but nothing big. And why did you get into rigging? I did not get into rigging. Rigging got into me. I did not choose this. And I don't know. It's just tinkering is something I've always done. Creatures is something that I've always looked at. When I started programming relatively early on, but not getting much results. But teenage kind of thing. I've always liked art as well. I've always loved creatures. When I was I don't know, maybe 15, 16, stuff like that, I started looking into animatronics, because before then I loved engines and electronics and stuff like that. So animatronics pretty much died. Luckily, I did not get into those, because they were starting to die by the time I would have had to basically pay my due and do all the painful stuff that you capitalize on later on in life, and then it would have been a dead market. So I always also like computers. I always had computers around, like CG. So I guess the closest thing I could get into that wasn't animatronics, but sort of looked like animatronics or had, sorry, a similar domain and similar feel was rigging, and I guess in those regards, and this was mid to late 90s, so it was a while ago. There was no digital tutors, like there weren't really rigging tutorials going around. This was with Lightwave that didn't even have IK, and then later on Softimage 3D. So there was a lot of pain. But yeah, I persisted, and it's kind of what I've been doing. Like, I don't even think of it as rigging, to be honest. I think of it as creature work, and I like pretty much the lot of it. The pipeline work behind it, being a pipeline supervisor for the animation department, I've been a rigging soup and stuff like that. So yeah, I don't know. It's just what I've always done. If I didn't do this, the only other thing I can probably do professionally is wait at tables. So are we going to write necessary stuff with CPP Pi at some point in the future, notes, the former stuff like that? Yes, abundantly. So thanks for asking that question, actually. Anybody who's done my workshops before, anybody who's worked with me and has been at my reading groups or training sessions and stuff like that in the last 15 years or whatever, I don't consider myself a programmer, but I've been programming for, well, at this point, most of my life, and definitely all of my adult life and a little bit before then. And I think it's unnecessary, and the same with maths. I think it's unnecessarily mystified, and people think it's hard. I've had great success working with people that consider themselves artists and not technical, learning scripting just fine, and with tedious and technical artists that thought, oh yeah, sure, I can script, I'm fine with that, but C++ or compiled languages, that's too deep, man, that's too deep. And it's like, no, C++ today is not C++, even just 6 or 7 years ago. It's a lot more approachable. It's actually a really good language these days. The IDEs and the compilers and all of that are amazing and free. Yes, we will do it, but I don't think of it as programming. For me, it's just part of the normal flow. At some point you get to something, and to escalate that something into quality, be it performance or proceduralism, you have to write code, and that's fine. It's not hard. So what people, such places would you suggest looking at for more rigging resources in general? So I don't know. I have never in my life followed a rigging tutorial. I mostly follow developers. So Handmade Hero, if you don't know it, handmadehero.org, I think the website is a stream, like it's the stream. Without Handmade Hero, there wouldn't be Cult of Rig, to be honest. It's a lot more development centric. It's actually code all the way through, and it's game development, but that's a great resource. If you can sit through it, have it as background noise or whatever, there is something to learn. There are a lot of like amazing like rigging TDs and rigging artists out there. Some of them are in this chat right now. I just don't follow websites and stuff like that. So would you ever move to developing a rigging engine evaluator outside of Maya, similar to something like Fabric? So here's the thing. There's a lot of stuff that has to do with my professional life, which is completely decoupled from this stream. So occasionally some things I will kind of have to avoid, even if it's not what I'm doing at work. Some things I might have to avoid anyway, because the can't comment thing means I cannot like really talk about things that we might intend to do at work or that we decided not to do at work, which is kind of funny. So the only way to make my work side of things, my professional, my professional employment completely decoupled from these and free of legal risks and, free of trouble for everybody, both myself and my employer, is some things I'm going to ignore entirely. Writing large systems and things like that, it is not what I want to do with this series. And what I'm going to talk about on these streams is purely going to be the stuff that I'm going to be doing in the series. Sorry, it's a non-answer, but it's the best I got. That said, I've done personally, like for myself, I've done stuff like that. I've done a rig that was entirely written as an OpenGL shader, purely to see how far the video card could be pushed. It's not quite a system. It's like the UI, the APIs and stuff like that tend to be the real work. The maths and things like that, once you know them, the manipulators, they're not that hard to write. The management to give that stuff in the hands of users is incredibly painful. I know you want to stay in Maya, but are we going to talk about Fabric at some point? Yeah, I don't see why not. I've actually, like, full disclosure, I know, several people in Autodesk who know about this stream. I know several people in Fabric who know about this stream. One of them is actually in the chat. Sure, I think Fabric is pretty great and people should try it. Like, the fact that I use Maya doesn't mean that you have to use Maya. Fabric actually is probably one of the few things out there that has parallelism, has, proper draw overrides and runs on the GPU, and has some pretty good visual debugging stuff. The more you try and follow what I do on a, in a context even just slightly different than the context I do it in, the more you're going to be practicing design and the first principles of it rather than repeating what I have done, which is probably going to be more useful. So I encourage you to actually use anything else. When it will come to code, there's pretty steep, there's an entry fee to pay to write code that, like, good code for any application, which is knowing the API. And that is a, more or less a one-time fee you pay for every application you use. And it's not terribly beneficial. It's not something that you don't get a lot. Sure, you get exposure to multiple APIs. You get some idea about development, design, patterns and stuff like that. But I don't think it's a fee worth paying many, many times. So when you start getting more into development, I would say choose an IDE, choose an application, try to pay as little as possible of that entry fee as possible, as it's possible for you. And if it's going to be Maya, you basically get to see the boilerplate for me, so it might make it slightly easier. Live version of XSI list is a go. Yeah, there's quite a few XSI names here. All right, so 2 minutes to go. Anything else? And with actually, let me type it in chat because that doesn't have a delay. I will take the one last question. All right, that's a good question, so I'm going to answer that one right away. What topics do you recommend studying to get a deeper understanding of the theories behind rigging? Damn, two good questions. All right, Kiki, if custom manips are on the docket, when do you think you'll tackle them? Yes, I will. Probably you're talking season 2 or 3. There is something that I want to do for custom manipulators when it comes to performance that is super important and I think people will like. But they require a lot of development background before we get to it. So there's other things that absolutely need to be done before then. Now, the other question that I said I really like is, what topics do you recommend studying to get a deeper understanding of the theories behind rigging? So here's the problem. Everything. The problem is there's a ton of stuff. Like linear algebra is super useful. Trigonometry is super useful. Calculus gets very, very useful. In order, I would probably say trig, or at least this is the order I'm going to go over things. Trigs, the very basics of linear algebra, a little bit of calculus probably much later on. Now, development-wise, I am not a fan of development dogmas and formalizing development, so I'm not a fan of anything getting a name, like, TDD is super prominent now, Agile, things like that. I don't care for those formalizations, so I can't really point in one direction and go deep in that one direction. But there's a couple books, and I might actually put a link in the description or something like that, which I very, very strongly recommend. One is Mathematics for Computer Graphics by John Vince. If you have very old editions, it used to be called Essential Mathematics for Computer Graphics Fast. That is an excellent book. If you pick it up and you read it page to page, you're doing yourself a favor. It's super approachable as well. And the other, now the For Dummies books get a lot of crap. Actually, there are some very good For Dummies books, and one that I've been suggesting people buy for a very long time now is Pre-Calc for Dummies, so Pre-Calc for Dummies is all the stuff that they did teach you in between elementary school and junior high, between 6 years and maybe 15 years. That you normally need to know something about to get into uni, and everybody forgets everything about. And it's pretty good. If you want a page-to-page or something that you can just go mix and match from. Anatomy is always good. Drawing, anything anatomical is always good for you. But the main thing is practice. Practice a lot. And whenever you do something, try to break it down to the simplest thing you can find. Research it, escalate your knowledge in that just as far as you need it, and move on. Iterate a lot. Don't get too stuck too deep for too long. Iteration yields the best in my experience, and that's what I'm going to try and do with this regularly. A couple times a week on weekends now, and hopefully more frequently than that if everything goes well after SIGGRAPH. And somebody was saying Rob's book on MyPython is on topic and probably free. Yeah. It's there's no link posting. I'll need to look into that, and I still need to mess with the Twitch chat. So yeah, there's a book on MyPython which has gone free or costed very little before. But yeah, anyway, I'll put some of the links in the description. So okay, 3 minutes over, but this is pretty good. I hope you guys liked it. I hope to see maybe all of you tomorrow, or most of you tomorrow. The ones that are not going to show up, I know it's going to be boring. Sorry, I know it was boring for you. Everybody else, I hope to see you tomorrow. So thank you for watching, and I'll see you in 22.5 hours maybe. Bye.